Hello YouTube. What I want to do in this video is take a look at arguments in the realism debate that appeal to features of scientific practice. The idea behind these arguments is that certain scientific practices presuppose a commitment to realism or anti-realism. Now actually we have touched on arguments along these lines already in this series in the course of talking about other topics, but I wanted to devote a video specifically to scientific practice arguments. Now first of all, we can distinguish two types of practice argument. The first type of practice argument specifies certain practices where engaging in those practices rationally requires either realism or anti-realism. So the claim would be that some scientific practice is important or essential to science, and in order to be rationally coherent, a person engaging in that practice must be a realist or an anti-realist. So this argument would conclude that certain scientific practices are incompatible, logically, or in some, as a matter of practical rationality, incompatible with realism or anti-realism. The second type of practice argument is a bit weaker. It says that realists or anti-realists are better able to engage in the practice. So you're not rationally required to be a realist or an anti-realist to engage in this practice, but it helps. Obviously, the first type of argument is the stronger one, and we'll begin with this first type of argument. Now, the obvious question here is, what exactly is meant by the claim that some practice requires one to be a realist or an anti-realist as a matter of rational coherence? Well, here's a useful analogy. Suppose that I'm praying to God and I genuinely expect my prayers to be answered. I expect a deity to manipulate the universe in some way in my favour. So my prayers are sincere. I'm not simply pretending to pray in order to be polite or anything along those lines. Well, in this case, arguably, rationality demands either that I be a realist about God or that I give up this practice. If I were an anti-realist about God engaging in this practice, there would be a kind of incoherence between my spiritual beliefs on the one hand and my actions and expectations on the other. Prayer, in this sense, is what we might call a theist-laden practice. To engage in that practice is to be a theist. Similarly then, scientific practice arguments of the first type attempt to identify scientific practices that are realist-laden or anti-realist-laden. To engage in such practices just is to be a realist or an anti-realist. Now, in fact, there are some practices that do unquestionably fit the bill here. Consider the practice of believing in theoretical entities. This is realist-laden in that to engage in this practice just is to be a realist. This practice is incompatible with an anti-realist account of science. This is fairly obvious, since realism is by definition the belief that some theoretical claims are true. If you believe in the existence of electrons, you just are a realist. What the anti-realist will say, of course, is that such a practice is not essential to science, in that a person can be a perfectly good scientist while remaining agnostic about electrons and other unobservables. But if this practice were essential to science, you could not rationally be a scientist without being a realist. The question for us is whether there are any practices that are important or essential to science that are realist-laden or anti-realist-laden. Now, we've already seen one realist argument along these lines. In the video on entity realism, Hacking's manipulation argument, at least under one interpretation, under the first interpretation of that argument that I discussed, Hacking is appealing to a kind of practical rationality or practical coherence. And you can check out the video on entity realism for the details on that argument. So what about other realist arguments? Well, one of the most famous realist arguments from practice is Putnam's conjunction argument, which appears in his book Mind, Language and Reality. The argument goes as follows. Suppose that scientists accepted theories T1 and T2, and that some observational claim, a hypothesis about observables, call it O, follows from the conjunction of T1 and T2, but it doesn't follow from either T1 or T2 in isolation. Now, both realists and anti-realists would presumably hold that scientists can believe O, because O is a claim about the observable world. Suppose that O is a claim about the effects of global warming that follows from the conjunction of a theory in oceanography and a theory in atmospheric physics or whatever, but it doesn't follow from either theory alone. Scientists infer from the conjunction of the two theories to the observational hypothesis. Now, for a realist, this is perfectly reasonable. If you believe that T1 is true and you believe that T2 is true, then you are logically committed to the conjunction T1 and T2. Right? The conjunction of two true theories is itself guaranteed to be true. So naturally you can infer all of the observational consequences of the conjunction. But consider the anti-realist, who claims that we should believe only that our theories are empirically adequate, that they are true of the observable world, but we should be agnostic about anything beyond that. Well, there's no guarantee that the conjunction of two empirically adequate theories is itself empirically adequate. Indeed, it's even possible that such a conjunction would be inconsistent. We can't infer from the empirical adequacy of T1 and T2 each in isolation that the conjunction T1 and T2 is empirically adequate. So the point is, using theory conjunctions to draw conclusions about the world, or at least about the observable world, is incompatible with anti-realism. And this is a problem because this kind of theory conjunction is a standard part of scientific development. It happens all the time. Scientists will frequently take a theory from one field as an auxiliary hypothesis in order to derive a prediction from a theory of another field. And we would be willing to provisionally believe that prediction and act on the basis of that prediction. Is this argument convincing? Well, there are some obvious problems. First of all, it seems like an anti-realist could simply bite the bullet and accept that we should withhold belief in the empirical adequacy of a theory conjunction until after that conjunction has been thoroughly tested. Of course, this would be a problem if we're trying to use the theory conjunction to guide our action, as in the case of the global warming example. But that arguably is more a matter of applying science to practical problems. In terms of theory development itself, it's not obvious why we would be required to believe that a theory conjunction is empirically adequate prior to testing it. A second objection is that anti-realists can account for theory conjunction perfectly well. Andrei Kukla, in his book Studies on Scientific Realism, suggests one anti-realist view that he calls conjunctive empiricism, distinguished from constructive empiricism. Kukla describes the difference as follows. For any theory T, Tx is the hypothesis that the observable consequences of T are true. The constructive empiricist says we should believe Tx, but nothing more. Now this gives rise to the conjunction objection. But now consider this. For any theory T, Ty is the hypothesis that the observable consequences of T, in conjunction with whatever auxiliary hypotheses are accepted, are true. Conjunctive empiricists say we should believe Ty, but nothing more. Now clearly, conjunctive empiricists have no problem accommodating belief in observable hypotheses obtained from theory conjunction. Perhaps the most serious problem with the conjunction argument is that it actually poses just as much of a threat to realists. The reason is that realists do not believe in the truth of the best theories, but only their approximate truth. It's obviously implausible to suppose that any of our theories are completely perfectly true. Even in the best of circumstances, our access to the world is partial and our resources for representing the world are limited. So every sensible realist claims at best approximate truth, not complete perfect truth, let's say. But from the fact that T1 is approximately true and T2 is approximately true, you can't infer that the conjunction T1 and T2 is approximately true. Indeed, the conjunction might even be inconsistent. So it would appear that realists are in the same boat as anti-realists with respect to theory conjunction. So yeah, some problems with the conjunction argument, I think. Okay, well, another realist argument from practice is suggested by Andrei Kukla in his book that I mentioned, and we might call this the elimination argument. Kukla says, suppose you have some theory T which posits various laws concerning the behaviour of unobservable entities, and this theory is very successful at predicting and explaining observable phenomena. Now, of course, realists take it that the success of this theory is good reason to think it's true, anti-realists don't. Now suppose, Kukla says, that a scientist wonders if one of the laws of T, call it L, and the unobservable entities corresponding to this law can be eliminated from the theory without altering the theory's predictions concerning observables. We might imagine a physicist in the 1800s wondering if he could remove all references to the luminiferous ether from the theory of light, while preserving the same empirical consequences. So, at the moment, L is used to derive some of the successful predictions of T, but the scientist thinks that there might be alternative ways to derive these predictions that are more computationally complex, but that don't appeal to L. So this will create a theory with a simpler ontology, but that is more difficult to use. The question is, should scientists bother pursuing this hunch? Well, a realist would say yes. The result of this investigation could significantly change their view of the world. We might still use the original theory for practical purposes, but we would base our beliefs on the new theory, the theory without L. However, for the anti-realist, it would appear that this is a complete waste of time, because by supposition, the elimination of L will have no empirical consequences. It'll have no consequences for the theory's claim about the observable. Furthermore, it will have no real practical utility, because we're supposing that the altered theory will be more difficult to use. It will be more complex in terms of its computational aspects. So here we have a scientific practice which the anti-realist can't account for, because presumably scientists would pursue this hunch, or at least they may pursue this hunch. They may pursue the elimination of L. That would be a worthwhile scientific activity, and the anti-realist supposedly can't account for that. Okay, so some problems with this argument. Well, first of all, as Kugler himself points out, actually, there are many other properties of theories beyond truth and practical utility that an anti-realist might care about. For example, an anti-realist might be in favour of trying to eliminate L in order to increase the beauty of the theory. We might be interested in theoretical beauty just for its own sake, in the same way that we appreciate the beauty of an artwork just for its own sake. Similarly, an anti-realist might care about the simplicity of a theory just for its own sake. So it looks like they could have, there would be some legitimate motivation for them to pursue the elimination of L. I think a more serious problem, though, is that this example is highly artificial, because in order for this example to work, we have to stipulate that the removal of L will not in any way change the empirical consequences of the theory, and also that it will make the theory more computationally complex. But in a real-life example, how could we possibly know these things prior to the investigation on L being carried out? How could we possibly know that removing L will create a version of the theory that's empirically equivalent rather than one with different empirical consequences? Perhaps, perhaps one that accommodates more phenomena, or solves problems that the earlier version of the theory had. I mean, actually, one obvious point here, of course, is that the empirical consequences of a theory, the predictions that you derive from a theory, depend not just on the theory itself, but also on the auxiliary theories that you're using. And those auxiliaries might change in unforeseen ways in the future, in such a way that would make a difference between the theory with L and the theory without L. So it's hard to see, even in principle, how we could ever be justified in thinking that altering a theory will have no empirical consequences. Final problem with this argument is that an anti-realist might argue that investigation into L is worthwhile, because during that investigation we might come up with methods, techniques, ideas and so on that could usefully be applied in other contexts, even if there is no greater practical utility to the altered theory. The process of investigating the theory might be fruitful. And I do think in general it seems that one reason why science is so successful is precisely because we allow scientists to pursue whatever questions interest them. We don't sort of try to set a priori boundaries on acceptable scientific inquiry. So, I mean, even if from an anti-realist point of view an investigation into L is probably pointless, we wouldn't want to say that scientists shouldn't do it. Even an anti-realist wouldn't want to say that scientists shouldn't do it, because quite a few investigations that seemed like they were probably pointless turned out to be fruitful. Yeah, I mean, it would appear then that neither of these arguments for realist-laden practices seem to work. There is, in fact, a very general objection to any realist argument from scientific practice. This objection seems to show that no such argument can be successful, no matter what its details are. So this objection is based on the point that it's always possible to appeal to the distinction between acceptance and belief, where accepting some theory T involves believing only that your observations will be as if T is true. In other words, when you accept T, you believe only that the observable world will behave as if T is true, but you don't believe anything about the unobservable. Now, point is, it would appear that any action that a scientist performs on the basis of T can be rationally justified by citing their acceptance of T. And notice that acceptance in this sense also appears to allow for theory conjunction, because part of what's involved in the world behaving as if T is true is that when you combine T with accepted auxiliaries, you will also get the right predictions there. So beyond trivial cases such as the practice of believing in unobservable entities, why would any practice that is dependent on some theory T require more than acceptance of T in order to be rationally coherent? So the suggestion of this argument is that, in principle, there are no realist-laden practices. I can always just cite my acceptance of T rather than my belief in T. Okay, anyway, so those were some arguments for realist-laden practices. What about anti-realist-laden practices? These are practices where engaging in such practices requires, as a matter of rational coherence, that you be an anti-realist. In fact, such practices seem to be quite prevalent in science. The use of models with idealized assumptions is one example. Scientists will frequently use models that include assumptions that contradict what we know about target systems. For example, when we model stars, we might treat the stars as being composed of ideal gases. This is simply false. There are no ideal gases in the real world. So this would seem to require an anti-realist interpretation. Or just take any case where scientists still use a theory that has been replaced by another. Scientists use T1 in certain contexts and T2 in certain contexts, where T1 and T2 are logically contradictory. Newtonian mechanics has been superseded by general relativity, but it's still applied in various contexts because it's simpler and it correctly describes the behavior of observables within a certain range of masses and velocities. Since these theories are incompatible, we're forced, as a matter of logical consistency, to be an anti-realist about at least one of them. And so scientists must sometimes adopt an anti-realist interpretation of the models and theories that they use. Here are practices that are anti-realist laden. Somebody who insists on a realist interpretation of all the models and theories they use can't coherently engage in these practices. I should note that this is just one type of argument appealing to idealized models and things like that. I mean, we discussed a few other arguments in the previous video on models and fictions. So, for example, another way to appeal to idealization in models is to use it to attack the realist inference from success to truth. That would be a slightly different type of argument. But no, the point here is just that there are indeed certain practices in science that seem quite clearly and uncontroversially to be anti-realist laden. However, it also appears clear that the anti-realist laden practice of using false models or false theories or whatever isn't enough for an argument for anti-realism. And this is because the realist only holds that some of the theories they use are true, or even just that some very specific parts of those theories are approximately true. An argument from anti-realist laden practices could only establish anti-realism if we could identify a practice that is used all the time for every part of every theory and every model, and it is hard to see what such a practice could be. But certainly the examples that I've just given don't count. When we identify some part of a model as an idealization, or when we use some theory that has been displaced, the use of that particular model and that particular theory is anti-realist-laden. But that is perfectly logically compatible with being a realist about other parts of the model or about other theories. So when we model the sun, let's say, we assume it's composed of an ideal gas. Okay, that's straightforwardly false. The claim about, because there are no ideal gases in the real world, but the claims that the model makes about certain features of the internal structure of the sun, say the division of the sun into radiative zone and convective zone or whatever, those claims may be true. So it's possible to be a realist about restricted parts of the model. After all, in many contexts, falsehoods can be useful tools for achieving the truth. Indeed, this is something that even anti-realists would accept, because anti-realists grant that our theories are true of the observable world, or at least most anti-realists grant that. They grant that science has achieved increasing truth about the observable over time. For an anti-realist, false theories are tools which can be used to predict and systematize the observable phenomena. So if falsehoods can play a role in achieving truth about the observable, why shouldn't they also play a role in achieving truth about the unobservable? Realists can use falsehoods as tools for discovering facts about the unobservable, just as anti-realists can use falsehoods as tools. I mean, it is an interesting and difficult question exactly how it is the case that falsehood can, in certain contexts, lead us to the truth. But that's a question that all philosophical interpretations of science must face beyond just complete radical skepticism. And this points, I think, to an interesting asymmetry in the scientific practice arguments for realists and anti-realists. If anti-realists succeed in identifying a practice that is anti-realist-laden, it looks like the most we can conclude from this is anti-realism about that specific practice. But this is no threat to realism, because the realist can simply exclude the claims associated with that practice from the class of claims that are given a realist interpretation. So when scientists apply a superseded theory like Newtonian mechanics, the realist simply accepts that this theory is false, but she can continue to hold that other theories are approximately true. So it's questionable whether the first type of scientific practice argument could succeed even in principle for an anti-realist. By contrast, if realists succeed in identifying a practice that is realist-laden, well, the anti-realist is in trouble. The anti-realist can't coherently engage in that practice. I mean, obviously the difference here arises because realists only hold that we're justified in believing that some claims about the unobservable world are true, whereas anti-realists are agnostic about all such claims. So that's where this asymmetry arises from. Anyway, ultimately, it would appear that the prospects for defending either realism or anti-realism on the basis of the first type of argument are, I think, rather dim. What about the second type of practice argument? This argument, recall, says that some practice is important or essential to science, and that realists or anti-realists are better able to perform the practice. So we're not claiming that it's a matter of like rational coherence. We're not claiming that that the practice is realist-laden or anti-realist-laden, that to engage in the practice just is to be a realist or anti-realist, but rather that realists or anti-realists are better able to perform the practice. A good example of this type of argument is what we might call the personality argument. This is discussed in Brad Ray's article, The Methodological Defense of Realism Scrutinized. The personality argument appeals to the supposed psychological traits of realists and anti-realists. As an argument for realism, it was proposed by both Karl Popper and Paul Feyerabend. Basically, the idea is that a commitment to realism will tend to make scientists more tenacious about defending their theories, which is helpful because theory development takes a huge amount of effort. Anti-realists are satisfied with theories that function as useful instruments for prediction and control. Only realists aim for theories that provide true descriptions of reality. So what happens when a theory faces apparently disconfirming evidence? For example, in the 1800s, when it was realised that the orbit of Uranus deviated from the predictions of Newtonian mechanics. Well, the thought is that a realist, committed to the claim that Newtonian mechanics is true, must therefore assume that one of the auxiliary assumptions is wrong, and they'll try to find a way to make the theory compatible with the evidence. For example, by positing another planet in the solar system and then doing the difficult theoretical work of determining the possible mass of the planet and its possible location and so on. An anti-realist, on the other hand, will be happy to simply abandon Newtonian mechanics the minute some other theory comes along that is compatible with the evidence. So the thought is that realists will develop stronger theories. They will develop the strongest theories they possibly can, because realists will try harder to defend their favoured theories from potential objections. They're not going to be so concerned about negative experimental results. They will try to find a way to accommodate those results. After all, since for the realist the theory is true, there must be an explanation for the results that doesn't involve giving up the theory. On the other hand, anti-realists have no reason to tenaciously defend a favoured theory. They will flit from one theory to the next just as soon as they notice any problems. And since it's better for science when theories are developed in their strongest possible forms, it's better to be a realist. Now, anti-realists have a personality argument as well. And their argument will be that the problem is that realism tends to make scientists dogmatic and unwilling to entertain potential alternatives. If you're a realist, you believe that your best theories are approximately true and therefore will not be discarded in the future. Yes, the theories may be altered in minor ways, and of course there may be plenty of things we don't know about the world that we still have yet to discover, but the central claims of our best theories will be preserved for as long as science goes on. So, while a realist might accuse an anti-realist of being too open-minded, the anti-realist can accuse the realist of being too conservative, too dogmatic. Now, the main problem with any personality argument along these lines is, what's the evidence that realists and anti-realists do significantly differ in the suggested ways? There doesn't seem to be any particular reason to think that anti-realists would not bother putting in the effort to develop a theory properly. After all, coming up with just one theory that accommodates a wide range of phenomena is an extraordinarily difficult achievement. Given the massive successes of Newtonian mechanics, it would have made perfect sense for an anti-realist to stick with that theory, to try to repair it, even in the face of potentially disconfirming evidence, simply because there were no plausible alternatives. Like Newtonian mechanics is pretty much all you had in the 1800s. And of course, once you do have a plausible alternative on the table, so for example, when general relativity was developed, it doesn't seem like there's anything particularly wrong with abandoning the old theory and favouring the new one instead. So I'm not sure there's any reason to believe that anti-realists would be problematically fickle. On the other hand, what about realists? Are they too dogmatic? Well, for one thing, just look at who proposed the personality argument for realism. Popper and Feyerabend. Feyerabend in particular must be one of the least dogmatic philosophers who worked in the field. And I think more generally, realists are well aware of the history of theory change in science. In my experience, realists expect that there will not be any major revolutions in the future, but they recognise that they might be wrong about that their expectation might be incorrect. And I don't think there's any reason to suppose that a realist would refuse to change her mind about an accepted theory if the evidence started to point in a different direction. Another point here, of course, is that even if realism and anti-realism were linked to attitudes to research as suggested by the personality arguments, I don't think there would be a clear case in favour of one or the other, just because science seems to depend on the interplay of both open-mindedness and dogmatism, of both revolutionary ideas and theoretical conservatism. You need some people coming up with bold new hypotheses, and you need some more conservative people tenaciously defending the old ones. It's the debate and argument and the clash between these two attitudes that seems to play an important role. It means that we are constantly sort of generating new ideas, but at the same time we're making sure that the currently accepted ideas are defended in their strongest possible forms. So it looks like you need both types of attitudes so maybe it would be better to just have both realists and anti-realists. That's Ray's conclusion, at least in his article on the subject. Okay then, a final argument that I want to note here is what I'm calling the reliability argument, which is given by Darrell Rowbottom in his article, A Methodological Argument Against Scientific Realism. So this is a scientific practice argument against realism. Now, Rowbottom first points out that most realists are committed to the claim that the methods used by scientists to arrive at their theoretical beliefs are reliable, in the sense that these methods tend to generate approximately true beliefs. And we'll call this the reliability thesis. So this is a thesis that scientific methods, whatever exactly these methods are, and of course there's plenty of debate about that, but whatever exactly these methods are, scientific methods reliably generate approximately true beliefs. Rowbottom argues that the reliability thesis has consequences for how science should be done, and this is where the problem lies. Its prescriptions are not followed and should not be followed by practicing scientists. Now, an important point to note here is that realists need not be committed to the reliability thesis in principle. After all, realism is simply the view that we are justified in believing that our best theories are true. There may be different ways of defending this view, and some of those defences may not rest on the claim that scientific methods reliably produce true beliefs. So Rowbottom doesn't argue that it's impossible for realism and scientific practice to be compatible. This is why it's not a type 1 scientific practice argument. But he does say that, in fact, many realists are committed to this thesis, and it's a sort of natural thesis for a realist to accept, I guess is the point here, whereas anti-realists don't need to be committed to anything like this. So what's the problem with this thesis? Well, it's helpful here to introduce some formalism. So we'll say that B denotes the content of a scientific belief. SM means was arrived at by scientific methods, and our little squiggly lines there means approximately true. And the reliability thesis then has the following form. And this says that the probability that B is approximately true, given that B was arrived at by scientific methods, is greater than N. So, what is the value of N? Well, that's difficult to say, and most realists would probably want to keep it vague. But remember that scientific methods are supposed to reliably lead to truth, so presumably N would need to be significantly greater than 1/2. The probability that a belief is approximately true, given that it was arrived at by reliable methods, surely that would be well over 1/2. Right? I mean, in order for those methods to count as reliable, if the probability that a belief arrived at by scientific methods is approximately true were only, say, 0.5, it wouldn't make sense to call those methods reliable methods. So we'll say that N is 0.8, but the exact number doesn't really matter. I mean, just as long as it's relatively high. Now suppose that the scientific community were to accept this claim. They were to accept that the probability that B is approximately true, given that B was arrived at by scientific methods, is greater than 0.8. And suppose that they hold a variety of beliefs that have been arrived at by such methods. The question is, what should they do when they consider some new hypothesis that contradicts the old beliefs? So we'll use C to denote the new hypothesis. Well, okay, we can say that the set of accepted scientific beliefs is B1, B2, B3, etc. Given our reliability thesis, it follows clearly that the probability that B1 is approximately true is greater than 0.8. The probability that B2 is approximately true is greater than 0.8, and so on. And this immediately tells that the probability that it is not the case that B1 is approximately true is less than 0.2. The probability that it is not the case that B2 is approximately true is less than 0.2, and so on. Now, the problem here is that C entails that it is not the case that B1 is approximately true. It is not the case that B2 is approximately true, etc. And as the number of accepted beliefs that contradict C increases, the probability that C is approximately true becomes extremely small. So if we suppose that the set of currently accepted hypotheses contradicting C contains only 5 members, right, B1 to B5, well then the probability that C is approximately true is less than 0.00032. And surely there's no point even considering a hypothesis with such a low probability. So the reliability thesis entails that a radical new hypothesis, which contradicts a large set of currently accepted hypotheses, is almost certainly false. No matter how much evidence is seemingly in favour of the new hypothesis, no matter how great its theoretical virtues may be, it's almost certainly false. Anybody who accepts the reliability thesis would have to retain the currently accepted scientific hypotheses, even if a very strong competitor emerged. And Rowbottom thinks that this is just wrong. While there may be some role for dogmatism in scientific practice, in particular, retaining a theory in the face of potentially disconfirming evidence or whatever, I mean, it's clear that if a hypothesis were developed which had similar empirical and theoretical virtues to the accepted theory, it would be worthwhile for scientists to take it seriously. So we should not accept the reliability thesis. Okay, well, we've sort of looked there at a variety of arguments appealing to scientific practice. One final question I guess I want to ask here is, who exactly is it that is committed to realism or anti-realism according to these practice arguments? If one of these arguments were to be successful, who would have to accept realism or anti-realism? Well, obviously, it's the scientists who engage in that practice. If we suppose that some scientific practice is realist-laden, say, then it's clear why scientists engaging in that practice should be realist. They're forced as a matter of practical coherence. But then what about the rest of us? Those of us who are not scientists, who are not engaging in the practice, are not forced as a matter of coherence to be realists. Recall the prayer analogy. If I'm sincerely praying to God and I expect that God will answer my prayers, rationality demands that I believe that God exists. But that's not an argument for theism, because plenty of people don't bother praying. Similarly, plenty of us are not scientists. In themselves, then, the scientific practice arguments don't actually give us the conclusion that realism or anti-realism is compelling, but only the conclusion that scientists should be realist or anti-realist. There's a further step involved in concluding that everybody else should accept the philosophical view in question. And it's not immediately obvious what the justification of this step is supposed to be. I mean, why exactly should we infer from the claim scientists should be realist because some scientific practices presuppose realism, to the conclusion anti-realism is unjustified? I mean, this problem is particularly serious given that the realism debate is a philosophical debate. Scientists are not the relevant experts. Philosophers need not endorse the conclusions of scientists, at least not with respect to philosophical topics. I mean, certainly there's a pretty strong case that we should defer to scientists with respect to empirical debates, because that's what scientists are experts on, but we don't need to share their philosophical views. So my point then is that there's a gap, as it were, in all of these scientific practice arguments that we've seen. Anybody who wants to give one of these arguments needs to consider how we move from a claim about which philosophical positions scientists are required to hold to a claim about which philosophical positions are actually justified. And there are, of course, obvious ways we might try to fill this gap. For example, we might take the naturalistic line that philosophy is or should be continuous with the sciences. Philosophy is itself in some sense a kind of science, or at least it is itself in some sense applies the same methods and should be judged according to the same standards as the sciences. This was most famously proposed by Quine. There are no distinctively philosophical methods, no distinctively philosophical standpoint. So, I suggested that philosophers need not endorse the conclusions of scientists with respect to philosophical topics, but for a Quinean naturalist, there's no sharp distinction between philosophy and science, and there are no specifically philosophical topics. If scientists should be realists, say, the same should go for philosophers. So that's one way we might try to fill this gap, but I just think it's worth bearing in mind that there is a gap here, and anybody who's proposing a practice argument needs to think about how they're going to bridge it. Okay, that's all for now. Thank you for watching. Goodbye.